The ASPEN OneLiner version 14 we shipped to you guys in March this year, and currently we are on the latest version of 14.4. The links to download that version were emailed to users in September this year. And if you are current on the software maintenance subscription with ASPEN, you can always write to request the download anytime to the ASPEN support. Okay. First, for today, I will describe to you a few enhancements that we've made in the phasor diagram, which is a tool that you guys are all using for monitoring the solution on the single diagram. Okay, so those are the summary of the new thing that we have made, and I will do some quick demo to show it to you later. First, this new phasor diagram is done in Graphic now, and it's designed to have all the capability of the classical version, which was done with text boxes and so on. And there's a lot of customization that you can do for this new graphic panel, and also it has some advanced solution monitoring feature that I'll show you in a couple of minutes. Okay, so this is the on the left, you see the classical phasor diagram that was there in OneLiner version 12 and earlier. On the right, this is how it looks now. So you see it's about 2/3 of the previous one, with everything same, with all the exact same information. You have the column for the voltage phasor, the column for the current phasor, and the column for the apparent impedance seen in the fault simulation at this point here. And you can also see that those apparent impedance is calculated with a certain K factor. Okay, and the same phasors are shown as graphic here. Okay, now let me switch to the program in order to show you how this new one works in the actual simulation. So if I run a fault simulation anywhere on the system, then I can right click on the point where I want to show the solution, select show phasor, and there are 3 different panels that I can select one location. I can select panel 2 for different location, and I can select panel 3 for different location. Okay, so on those panel are resizable. You can make it smaller. Okay, and if you have a good eye, you can also bring up the properties by double click on anywhere on the phasor, or you can right click and select properties, or you can just go to the menu, the properties, okay, and then you can actually even change the, say for example, the font size to make it look nicer. Okay, and if you if you make this change and you close it, the next time you open it, it will retain that size and shape. Okay, now you saw how I've opened this last one with a shortcut, which is I push the key, the control key on the keyboard, and I just double click the mouse where I wanted the phasor to appear. So double click, I get another phasor for this end, and double click with the control key, I have the third phasor. So now if I go and run another fault simulation, further here, you see all the results on everywhere are updated to show the new solution, and I can go back to the previous fault solution and on the number as adjust it to show that. Okay, so that is how the phasor has been working all along, and now this is the same thing you can find in this new version, except that this is the graphic display that has more flexibility. So one of those kind of flexibility I showed you before, which is the resizing. Okay, another. So when you open this property by either double click anywhere or go to the menu or right click, you get this full page of different options that you can customize. So that's the customizable part. Okay. I must point out to you that all the previous version feature should be here. For example, you can select to show the line-to-line voltage instead of phase voltage. So then you can make it here, or you can also make the same change with the right-click menu. Right-click and say show sequence voltage, and the show sequence current. Okay, so I admit I can agree with you that this now take 2 clicks to change the quantity from the right click and the click to change it. And if you compare to the this old interface, you just single click, you can move from one kind of quantity to the other. But we feel that that kind of that sacrifice is kind of okay price to pay in order to get the better look and the more flexibility of the graphic. Okay, now you can even if you want, you can even make this thing more compact by say uncheck this show menu toolbar. And now you can see that the toolbar is gone, and you have slightly smaller. You can make it slightly smaller, and that way you can see more behind the scene here. Okay. Now the toolbar, once each toolbar disappear, there's this pop-up button here. If you click, you'll get the everything that you need to make the adjustment for the quantities here. Okay. Now, there's a number of things that you can customize in this new phasor diagram. On the side, I show you the font. I show you. Oh, by the way, if you want to, you can also highlight the text here and click copy, and then you can say open your notepad and paste it. Okay. Now in the previous version example, you can copy and paste only one of those things at a time. So that's we feel that it's another better flexibility that we have that you have with this new interface. Okay. So now I will double click here to bring up this option, and then we'll show you that there's a number of other things that you can customize. For example, you can, instead of showing the voltage and the current separately, you can uncheck this button to show them in the same graph so that you can compare the angle easier, for example. Or you can, instead of showing the phase angle at 0 to 360, as like checked here, if you uncheck, you'll see that the angle will be between 0 and 180 and 0 and minus 180. So depending on your preferences, and also depending on how you want those vectors to be shown, you can select either of those. And I think the 0 to 360 option is usually the selection you want to do, 0 to 360. You want to use, if you want to compare those phasor with to some other external calculation or event recording where the phase angle is being written that way. Okay, so there's those kind of flexibility that you have with this new phasor diagram. Okay, and then talking about comparison of this phasor to something else, the program also gives you in this new version some additional capability, and show it to you right now. So if you open that, double click to open this panel again, you will see that in the middle here, there's some a part for you to enter so-called additional markers. That will be voltages and current that you can enter. And let's see how would that look here. So if I enter some current, for example, 3500 at an angle of 15, then if I click here, you see that the angle, and I see an additional vector with the IA star, IA asterisk label, and it's shown at the location that I added. So I can also try to add a voltage vector, for example. For example, I will enter 6.5 at the angle 0. In addition, then I see the 6.5 here. So when I change the solution from one form to another, and those marker will let me see the or compare the solution in OneLiner to those fixed quantity easier graphically. Okay, so if I say run another form simulation here, you can see those vector kind of more or less, you can see how far or how close they are graphically. Okay. Sometimes you can also, if it would make it easier if you have more than one quantity, for example, instead of, in addition to the A, you can also enter VB at 5.5 at the angle of 175, for example. Okay. Now, so to make it easier to compare those numbers, you can also have the program align those markers to one of these calculated values so that you can see everything in the correct proportion. That's free because when you get the external calculation in angle, they may or may not be of the same reference as the one-liner calculation. So if I say align everything with phase A of the voltage, then you see that now phase A of the marker and phase A of the solution will always be aligned, and everything else is being rotated correctly to show you the match. Okay. All right, so that's the customizable and the additional capability of matching the numbers. There's the last thing I want to show you about this phasor in the new OneLiner version 14 is that you can get those output to the external report or external software easier with a couple of the commands. The first command that I want to show you is to, if you right click, you can say print the text result to TTY, and you will see that the TTY now will have the all the number that's being displayed in the graphic in this text table format. Okay, so you can copy and get those numbers to your say report that you're writing, for example. You can also right click on this phasor and say copy to clipboard. And if the clipboard result will be of the same content of the TTY report like that, but it is formatted so that you can paste it easy and correctly with cells and column in Excel. Okay. Okay, so so that way, if you have a spreadsheet that you have developed that takes into account those current voltage inputs, you can copy it and paste it to the spreadsheet, and you get the calculation done right away. And the same thing will apply to other calculation software, for example, MathCAD or MATLAB. So all those numbers are pasted in a in the well-defined cells and rows and columns. Okay. By the way, I want to highlight the fact that if you compare this Excel report to the TTY report, they are one-to-one match. For example, this will be the positive sequence voltage in this column. If you look down here, the positive sequence voltage, and this will be the positive sequence current, because I look down here in the text file. So this will be also the positive sequence voltage, and this is also positive sequence current. But if you look closely at the numbers, you will see that the numbers in Excel are already split into rectangular format for you to make it easier for you to perform the calculation instead of the polar format that is printed in the text for human consumption. Okay, so the copy and paste, the copy and phasor command is basically very optimized to get you to get the data out for the further calculations. So all those numbers are now in the Excel copy and paste. They are already split in real and imaginary part instead of showing in the magnitude and angle. Okay, so that's an early small note that I want to make. All right, so that is the few remark about the phasor diagram and the graphic phasor diagram that you have in version 14, and I hope that you will find it useful and start to try to apply that. All right, so I'll go to the next topic that I want to cover. It's kind of related to what we showed you briefly earlier. Is this about the for locator command that you know that's found under the default section of the OneLiner menu. And the for locator command has been there before, but in version 14 we have made a number of important changes to it and make it work much more with a much better result. Okay, so I'll show you how it works in a real example, which I will open now. Okay, so let me open another file. And let's see. Okay, this is an example that I want to use to show you how this for locator command is working. So in this example, at this location here on this line, we have a for recording device, maybe a relay or a for recorder that had just recorded an event that happened somewhere on this line. Okay, so that event is recorded as a voltage and current. So we want to locate the location of that event. Where is that on the line using this method, which is we would try to run, say, a bunch of intermediate for on this line, sliding it every few percent. Okay, and then you would then open the phasor, and then you will have the recording, which I will say load from an event file instead of adding to here one by one. I just load it from an event file, And then when I open an event file, which is incomplete or could be incomplete, or could be in the SCL format, the CEV or the EVE format. I see the waveform that was recorded there, and then I just pick the part that corresponds to the fall and for the event, and the phasor will be copied here. So I will maybe align everything on phase A, and I start sliding the fall until I see that everything is matching. Okay, so that's the kind of this is the kind of simulation that you would have done by hand to locate this fall. So looks like I am getting very near. You see those vectors are almost on top of each other now. So this most likely that is where the fall took place. And we will look at that. It's about 30% on this small segment. No, 30% on the whole line, or that's about 71% on these segments here. Okay, so that is basically the idea behind the fall locator. Okay, but there with two important enhancements. Okay, the first, the comparison that the program is performing is not based on just the voltage or the current, but actually the comparison between the simulation and the actual value is done based on the apparent impedance that measures between the recorded position and the fall, and compare and the impedance are being used for the matching. Okay, and also the second distinction is that here what I had done, I simulate about 20 fall, and I just need to scroll it back and forth, and then that's kind of linear. The program, if in the next demonstration, I show it to you that the program is using more simulation for that search is a little bit more intelligently. Okay, so let me show you how this fall locator command will work for this same case. I will right click on the location of the recorder. I will say fall locator. Then again, I read all the phasor that was recorded for this fall from file. Okay, so I get the same file, and I take the part that is correspond to the fall. And when I click OK now, the program will repeat my search before, but in a kind of automatic way. Okay. Okay, so those are the input that was done from the recording value. We don't know what happened on the line. So what we want to do is to find the best simulation that matches this recording, right? So let's see how it's done in the software. If when I click OK now, the program based on those numbers suggests that this must be the A to ground fall, and I think it makes sense because the phase A current is quite higher compared to the other phases, and the phase A voltage is looks like much lower than the other voltage. And when I click OK, then the search for the best match will occur, and you see first it arrived at 50% exactly on the line, and also it's if I print it if I print the result on the TTY, it tell me exactly this is the what the input, and this is the simulation that matches this the best. Okay, and because I have the line length as part of the line data, it's not only showing it in ohms and the percent, it also tells me how many miles is between the recorder and the fall. Okay, so and see what kind of search the program perform. And if you click on this button and trace through all the simulation that is done, you see this is performing but every 5% up to a certain point, and then when it sees overshoot, it came back. And then it's also, when it's near, it become near the position, it will try different fall impedance as well. With R here is 1 and 0.5 and so on. Try to gather the best match. So if the event that you recorded is done, took place with a certain fall resistance, this search will certainly let you get quite near to it too, because it is not just looking for simulation without resistance. It's also try different level of resistance to see if best match. Okay. Now I can show that in another example, which I repeat the fall location again, but this time I will read the input from a different recording. When I done this recording, I know that this event happened with the 10 ohms resistance. So this is the fault that happened with 10 ohm resistance. Okay, and now if I run the search with that different set of input to see if the program can still get to the correct location, I go through the menu sequence again, and yes, it still arrived at more or less 50% of this segment. Okay, pin report or TTY. So it's yeah, it's about 6 point something mile. So I guess this shows that the search that being done this way is quite immune to the amount of fall resistance that was involved during the event. And that is again the result of the fact that we are using the apparent impedance to compare in the search, and also we also perform the simulation with different level of resistance. And also another fact that in the search we give more weight to the reactant part of the impedance and we kind of give less weight to the resistant part, and that results into quite a reliable search result. Okay, it also also quite reliable. In this way, I also say if I make this experiment, okay, let me go and change my model by taking this source on this end out of service, and then if I repeat that, I will repeat that solution, that location again. So in this case, when I do this fall locator, I don't have the same model configuration that my system was at the time of the event. And of course, you can see that that is one of the things that can happen quite often in the model. You can take line in and out service, generator, and so on. And you sometimes don't know whether the system that you have for location matches fully the condition of the system when that recording was made. And you can make that comparison, but sometimes it takes so long to make that match. Okay, so but you can see that because of the methodology, the search that we use here, this exact match doesn't even have to be there. So I repeat that search again with this line out of service and this file here, and if I just go to it and search for it, you see that I still get the same 50% best match here. Okay, and that happened because we do the matching with the apparent impedance between the recording and the fall. And if you have the source information on this side or this side change a little bit, it shouldn't be affecting the apparent impedance that you see here too much. So this is kind of insensitive to that. Okay, so of course, if you have a two line that is parallel, or a part of this line, the tau service, and this it's not match the real condition, then that may give you a bigger error. But for a number of other things, like if you have a source on this side enable or disable, or this side enable or disable, you will still get the correct apparent impedance calculation, and that's how you can find the best match for the locator. You can even, if you have the recording at both ends of the line, you can also improve the search that way by enter the information from both ends. And the way to enter the information from both ends for the same event is that if you do have those, you will want to highlight one end with a single click of the left mouse, and then with the shift key on the keyboard down, right click on the second end, and then in the pop-up menu, because you use the right click on the second click, you get this pop-up menu, and it's a for locator. And now you see that you can enter the phasor for the end at this 144 bus, and you can enter the phasor for 163 buses. And this the same impedance-based methodology is being used, so you do not have those phasor aligned with the same angle. Okay, so that's one thing. So that you do need to pick it from more or less the same point in time or very near, but you don't have to absolutely align them with the phase angle, which sometimes, because without the special equipment, those recording are very difficult to make. That would become a synchro phasor almost. Okay, so you can try that if you when you have the next event that's happening. And I am not saying that this is the always accurate, 100% accurate, but now what I want to explain here is how this thing works, and you will be able to make the best adjustment whether the event that you have with the data that you have and the model that you have, whether and when and whether this method will work, and then at least it gives you some guesstimate. Okay. Now there was a question: how about the three-terminal line? So, for example, if I had a line going from here somewhere else as well, then yes, the search will just start from the relay location, and it just go in all direction until it finds the best match. So the three-terminal lines should work. Now this method should work for the three-terminal line as well. Okay. All right, so let me go further to another item in the new that I want to show you guys today. That's about the mutual coupling model that we introduced in version 14.4. It will allow you now to allow the multiple from and to section for each pair of line without the use of fictitious sub buses. And again, I want to emphasize that this one is fully backward compatible. I'll show you what I mean in this example. Okay, so if I open a file here that's called section, and you see that this has no, actually I want to have this this example here. Okay, now if you have a line between Glenlyn and Claytor that happen to go together for a certain distance, and then they go apart and then come back together for a certain distance. This is an application for in the new version where you can enter this mutual couple section and this mutual couple section for the same pair between those two lines. And the way you do that is here. You will enter the from and to for the first line and from and to for the second line. That's it for this part. 0 to 20, 0 to 20, 0 to 10, 0 to 10 here because this line is longer. Okay. And then here from 90 to 100 and from 90 to 100 and from 80 to 100. Okay, so this is still one mutual pair. Okay, then if you compare that to what it used to be, you have only one pair and then you have only one number. So if for this case it's impossible, for that example it will be impossible to represent it. And what you will have to do in this case, if you use the old version, is to put a tab bus here and another tab bus here and a tab bus here and another tab. So you need to put like 4 tab buses there to correctly represent this, or maybe if you need to do that on this line too. So there's a lot more tab buses that cloud make your model is very difficult to read. Okay, so this mutual pair here in version 14.4 and later we'll let you define up to 5 those here, section here without any tab bus requirement. Okay, and in this example, obviously you will see that you can have 2 again, 0 to 10, 0 to 10. That match 0 to 20 on the second line here, and then 0 to 90 to 100, 90 to 100 matches 80 to 100, 80 to 100. So this line is shorter, so the percentage like a little bit longer. Okay. Now there's another important change that we made in this mutual pair dialog box is this button here. Okay. When you click on this button, what will happen is that it will swap the display of those 2 buses. And why is it important? Because when you talk about percent, you need to say, if you need to know where that's measured from, right? So if you measure from plateau, that will be different than you measure from Glen Lynn. So with this swap ends, you will know exactly where it will be able to define exactly where this percent measurement is done from. Okay, and I'll show you in a quick example right now that why is it important. Okay, now if I take these 2 lines here, let me there's an existing mutual pair. Let me remove it and say if I add a mutual pair. Click on one and right click on the second with the shift key, say new mutual pair. I will see here when it pops up is that the line 1 is entered in this model as from plateau to Glen Lynn, which is line 1 here. So the measurement of the percent will be done from plateau, but then this line 2 here is recorded from Glen Lynn to plateau. But you know that we do know that they will go from Glen Lynn to plateau or the other way, right? So, but when somebody entered the line 2, they happen to pick Glen Lynn first. So now we have this situation, okay? So in this is the main, the prime example of why the swap end will works, because now I have those 2 line matching. So all the percent I enter will now have a consistent meaning, okay? Then if those 2 lines already showing in the correct orientation for me, then I don't have to use the swap end. But then if they don't, then this swap end will help me define everything correctly and consistently. Now let's compare that to the what used to be in the previous version. Okay, so in this is I'm running the version 12.6 here, and it's the same pair. If I open the data, you will see that in the previous version, in order to indicate, because there was no the swap end, and the two lines are shown this way, I had to enter the minus here, a minus here and here, to tell the program that when it performs calculation, one of those two lines has to be reversed to match what they actually on the field. Okay, and again, this happened because when someone enters the line 1, they select one orientation, and when someone adds the line 2 to the same circuit, to the same network, they happen to select the opposite orientation. So this got recorded in the network model, and it's showing up like here, and it can kind of confuse a lot if you enter mutual coupling with percent and so on. Now you don't have to use the minus here. Actually, in the new version, actually, if you try to enter minus, the program will not let you. But you better use the swap end. Okay. Say if I enter some number here, if I use a minus, when I click OK, the program, I think it will not let you. Yeah, so it will not let you use a negative value. Okay, so so you need to use that swap end to make sure that the orientation is correct. Now remember, the swap end just adjust the display of that line for you to enter the number easier with a better, more consistent reference. It does not, however, actually modify this how this line is recorded. Okay, so this one still show Glen Lynn to play tour, and this one still show play tour to Glen Lynn. So that means now what that means is that this is just basically a way for us to kind of hide that minus sign from you and make it easier to see. Okay, so that minus sign, so it caused a lot of questions and wondering before, because people would say mutual coupling impedance, no, they cannot be negative. Okay, and so on and so forth. All right, so that's just what happened here. If you enter before, if you enter the let me close this and not open so that we can compare. Close is not safe. Let me open it again. If we look at this pair here, we see that it will go from 0 to 80% on one side and 0 to 80% on the other line, if you do not count this section separation of the section. And that is what you will get from the version 12. If you open the same file in version 12, you'll see that from 0 to 80, and of course, because the other line is reversed, it's so from 20 to 100. So this is kind of backward compatible. When you open that line that you create with multiple sections in the previous version, it's kind of still get some of the data, but now you lost those, meaning that this actually composed of the two sections that's not intersecting. So that's a kind of backward compatible, but of course it's not fully. Okay. All right. So that is the mutual coupling. And lastly, I want to show you some small enhancements in the reporting of the fault clearing results, simulation results. So With the by fault clearing simulation, I mean the so-called step event analysis. Now let me just go straight into that example here. Let me open another file. Where's the step event? Okay, so in this, if I highlight this bus here and select the step event analysis and specify the fault, the program will perform a simulation and tell me what is the process of this fault being cleared. Okay, so first, if I play the first step, you will see that a breaker here open, the fault is still there. And then the next step, the second breaker open, that prevents the current going this way, but that still is the fault being fed from this end. And then lastly, only after the 3 steps, this whole thing is clear. So this is a fault clearing simulation. And we made a small enhancements in this report that let you easily document and summarize this fault clearing process. And it is in the format of this right click here and say copy Windows content to clipboard. Okay. If I paste that again to an Excel spreadsheet, you will see that again the data is optimized for Excel and Matcat paste. Everything pastes in row and column. You will see that those are the step number for this fault clearing, and this is the initial fault. Now, watch I think the 2 important information, the columns with important information are those 2. First is the timestamp, and the second is the current. We can see that as the time progresses, the current reduces. Okay, so that is actually describing the actual evaluation of that current over time. And that is enhancement that I was talking about. So, okay, so on this screen over here, you can kind of see the time, but if you want the current, you have to watch here, okay? And in this copy and paste, you have them all organized neatly in this spreadsheet. And one kind of study that I found that this kind of information become quite valuable is the arc flash hazard calculation. Okay, so if your task, your study is to assess how much arc energy would appear here if you have that fault, and it will be proportional to the fault current, and also how long that current is lasting. Okay, so of course, if you took the 8,640 and make it last all 100.1.2 seconds, you will have much more energy than if you are able to tracing that. So 8,600 will last only about 0.14 seconds, and then it dropped to 8,300, and it lasts for another 2.2 seconds, and then it dropped to 7,500 for another less than a second. Okay, so this kind of information is, I think, very valuable in the arc flash calculation. And you can do this not only on the bus, but if you can also run the fault simulation on run the fault clearance with a step event analysis on the line, say 40% on this line, then you will get the similar kind of report which show which breaker open first and how this fault is being cleared. Okay, so and then you can bring the information to the Excel spreadsheet and run that analysis for the arc flash. Now, as you know, OneLiner also has built-in arc flash calculator. Okay, and it uses the energy calculation from the IEEE 1584 standard. Okay, so then in this version 14, we have added this option to use this kind of fault clearing simulation to determine how this arc duration is calculated. And if you select this option in version 14, the program would use exactly this kind of sequence of current and voltage, current and time to show you the total arc energy. So it will actually take this the duration or the current of 8600 for the duration of 0.14, and then the current of 8300 for the duration of 0.2 more seconds, and so on. So this step event simulation, an option for the arc flash calculator is new, and if you want, you can make use of that. So it will be more accurate, in our opinion, compared to other options that used to be there before. Oh, sorry. So either before, you can either use a fixed duration for the arc, either use the one of those relays in the vicinity. But we saw in this example, even this option is not accurate because it took more than one relays operation to clear this fault. Okay, and after each operation, the current is changed. Okay, so this option is again part of this fault clearing simulation enhancement, report enhancement. So this simulation is not new, but the enhancement for the reporting and the application, direct application to the arc flash calculation is new in this version. All right. There's a couple. There will be more. You'll find more graphical enhancement in this version. I'm not going to go into them in details because of the time we don't have. But you can play with them easily. For example, when you go to the program and press the E key to go from one line end to another, you will see that if the line has tabs or at the middle point, the program will show you a graphics displayed on all of those so that you can pick the correct end to go to. And if you go to the relay group on second page and click on that plus button to add a new backup or new primary position for that relay group, you'll see the graphic display of other relay groups in the vicinity that let you determine very easily which one ought to be backup and which one ought to be the primary. Okay. Okay, so those are the content that I wanted to cover today, and I hope you'll find them useful and can find a good application for them. I just want to let you know that we'll continue this kind of mini seminar in the future. In the next one will be about 2 or 3 weeks from now, December 7 and December 8, with the topics of that cover different things about wide area relay coordination tool in ASPEN OneLiner. We'll be covering the existing command and also a couple of new things that you'll find in the program. And the next ASPEN OneLiner class is going to be in Burlingame, California, in first week of March. On those events, registration can be found and performed online on ASPEN website on the event page. So just go there and see more details, and you can click on the registration link there. Okay. And that's all I have for today. And if you have any questions, feel free to write to ASPEN or call us